Greetings and welcome to another Dev Bootstrap screencast. In this screencast, we're going to cover Amazon Web Services Fargate services. We're going to run through an end-to-end demo of building and deploying our own custom container to Amazon Fargate, running that container and seeing how that works with load balancers, and also it's going to be connecting to its own private database running in RDS. We'll also look at security and how we can manage security groups to make sure that the services can communicate effectively between each other. So without further ado, let's take a look at Amazon Fargate and what it is all about. So if you head over to Amazon Web Services website, you can go to the Amazon Fargate page here, and you can see it describes itself as being a container service that works with ECS and EKS, and it makes it easy for you to build and focus on the deployment of your application. So what does that mean really? So, well, let's scroll down and look at the differences between using Fargate and not using Fargate. So here you can see in this diagram on the left here how your life might be if you did not use Fargate. So you would be building your container, you would then have to define and deploy all your EC2 instances, which of course would need to run Docker, a Docker host or a Docker runtime on there. Of course you need to provision and manage memory, think about isolation, think about scalability, and then monitoring, logging, and so on and so on. And this becomes pretty complex. This sort of orchestration being done manually by yourself is going to be a bit of a headache. So on the right side here we use Fargate, and Fargate, as you can see, simplifies the process quite considerably because it takes care of the containerization and the orchestration management of your services. So all you need to do, as stated in the on the tin, so to speak, is to build your application, build the container image, define the resources in terms of memory and compute power that you need, but you don't need to actually provision that yourself. That is managed by Fargate. And then you just tell Fargate to run your application. So literally you just have a container and you say, yeah, this container needs 1 gigabyte of RAM and a dual processor. Just run this container like that. Just run it with an IP address. I'm not really worried about putting it in front of any sort of public-facing load balancer. Maybe you do that because it's a task that you want to run periodically. Or, of course, you can have you can tell Fargate, please run 2 instances of this container behind a load balancer and distribute the traffic between the 2 containers. You can also include scaling, auto-scaling, so you can say, okay, I want between 2 and 6 containers, depending on the traffic. You can configure the triggers that cause the scaling to go up or down, and so on and so on. You get the picture that it's actually a pretty nice and flexible service for containerization and running your apps in the cloud. So there's a few components, a few things to think about when you're working with ECS, and I've just copied this diagram from the Fargate terminal. So you see there's the container, the task, the service, and the cluster. And the container is really something that we're already familiar with. It's basically our Docker container that we use to deploy our app and run. A task and a task definition is essentially a blueprint for your application, and it describes one or more of the containers that you want to run through various attributes. And these may or may not override the attributes or the settings in your container. But mostly the attributes and settings and environment variables and so on will be set in your container. And in your task, you might define things like the amount of memory and the CPU that you wish to use for running your container. The service itself is basically allowing you to run and maintain a specified number of these tasks. So when you define a service, this is where you say, okay, yeah, I want to have 1 task or 20 tasks, and whether or not you want to have a load balancer, whether or not you want to have auto scaling and that kind of thing. That's where you define that is in your service. And finally, the cluster level is basically the infrastructure level of Fargate, which is managed by Amazon Web Services. And this just basically allows you to run all of this in a serverless type of manner. All right, let's have a look at the demo app that we're going to be running. So here I've got a demo app already cloned from the dev bootstrap repository. The link to that will be in the bottom, in the comments under the video here. And let's take a look at this application. Take a look here in the source code, and I'll just show you quickly the Docker Compose file, and it's a simple Ruby on Rails app. Now, there's no it doesn't matter what the application is. It can be a Python Flask app, it can be a Node.js app, it can be, as in this case, a Ruby on Rails app. It can be anything, right? I just happen to have this Rails demo app lying around. It was already containerized, and this is what I thought I'd just use to do this. So it's already configured and set up and ready to run using this Docker Compose in local environments. So I can spin this up now using Docker Compose up, and this will spin up that service. So it's going to spin up the database, and it's going to spin up the web service like so, and attach them. And then if we go over here to another terminal window, I can do Docker PS. And here you can see the processes. Just make that a little bit easier to read. Yeah, so we can see here, the container IDs and the services that are running, the ports and so on and so on. And here you can see that the app has started and it's listening on port 3000. So we can head back over to the browser and we can open up localhost 3000, and it will open up the application. And this is a scaffolded Rails application. If you're not familiar with Rails, it's just like any other kind of MVC type framework. And what it's doing is it's got this index page of products and services, and then I've got this from your host, comma, and then this number. This number is actually useful for when we deploy this container onto Fargate, when we want to run multiple instances of it, because then we can see when we hit refresh which instance of the container that's running does our load balancer and Fargate respond with, and it's just useful for that. At the moment you can see here that this number here actually corresponds to our container ID right here for that service. So that's the application, and this is what we're going to deploy to Fargate right now. So how do we start off with Fargate? Well, first of all, of course, you need an Amazon Web Services account. You need to log in, yada, yada, yada. I've already done that. I'm not going to go through that right now. And the other thing is, for this demo, or let's say for parts of this demo, I'm going to use the Amazon Web Services CLI. Let's just take a look at that quickly, AWS CLI. And this is it here. So you need to install the Amazon Web Services CLI, right? It's a very cool tool because you can then run commands like this, AWS EC2 describing instances or whatever it is you're using, and it will work for you. So I've already done that. Let me head over to my terminal window here. I'm going to open this up here, and I'm going to do AWS ECS help. Okay, and this is basically showing me a list of commands that I have available for my command. So here's one, describe clusters, right? So if I run that command, AWS ECS describe clusters, you can see here that there are no clusters in my account right now, which is as expected. And by the way, when you install the AWS CLI, you need to configure it with your own AWS key and secret, which you get from your IAM. Again, I'm not going to go through that in this tutorial. You can find plenty of resources that do that. So I'm assuming that we're starting off on the same foot. That is, we both have an Amazon account already created, and we have the AWS CLI tool already installed. Let's have a look here. Let's just see what version am I running. Yeah, so I'm running 2039 on Python 3.8.5. Okay, so if we go back to our diagram here, we can see that we need to create these things. We need to create a container definition, a task definition, a service, and a cluster. Actually, what we also need to do before all of that is create a repository. So this is where we need to start. Now, as you can see, I've already created a repository here, and it's called Demo Rails. Actually, what I'll do is I'll delete it, and I'll create it again, but I'll create it with the AWS ECR command. So this is the command to create a repository using AWS CLI. You use AWS ECR, create repository, and you give the repository a name. And you hit enter, and it's going to go off and create that for you. And there's the response. You get a JSON response to say that it's successful. And if we head back over to the terminal or the AWS console here, we can see it's been recreated. Now, if we click into that, there are no images in our repository. So what we need to do is we need to build and then push that image, an image to our repository so that we can then deploy that. So if we take a look at the source code again, you'll see that there is a Dockerfile. And the Dockerfile is going to basically use Ruby, and it's going to run a bunch of things to install the gems and set up a expose port 3000 and then run the Rails server. This Dockerfile is what was built using Docker Compose, but I'm going to build it using a standalone Docker build command like this, where I tag the image Rails 6 demo latest. Cool, so that's actually complete now. So what we can do is we can tag the repository like so. And you can see here, this is a Docker command, Docker tag, and it's saying tag this image that we just created with this tag here. And you'll notice that that tag is the same name as the repository that we created. In fact, if we go to AWS ECR, Elastic Container Repository Registry, and we run the describe repositories command, we can see that that is our repository name, and we're just basically saying, yeah, tag our image using that name with the latest appended to it like so. So if we look at Docker images on our local machine now, you can see here that we've got the Rails 6 demo, the top two here. So you've got Rails 6 demo latest, and which has the image ID of CB24, etc. And then we have this other repository here, which is tagged like this with latest, and it's the same image ID. So this is what we're going to use to be able to push our container to ECR. Now, before we do that, we need to actually authenticate Docker with ECR. So we run this command to do that. This is another ECR command. It's get login password. We pass in the region, and then we feed that authentication into a Docker login command using the username AWS and the name of our actual ECR repository there. So once we get that login succeeded, we are now free to push the Docker image that we just tagged up to our ECR repository in Amazon. And as you can see, it's a standard sort of Docker push where it's pushing each layer to our remote repository. You might, if you've used a service like Docker Hub or others, you may be familiar with this already. Essentially, the ECR service is very similar to Docker Hub. So we'll just wait for this to finish. Great, so it looks like that has updated to Amazon and pushed that image to our repository. Let's head over to the repository and take a quick look at that. So if we click on the repository name, you can see there the image. The image tag there is latest. And if you click on that, you can see some information about the image, the size, whether or not there was some scanning. And scanning it will scan for vulnerabilities and that kind of thing. You can also encrypt the image and many other things. So take a look at that in your own time. Now, what's next? Well, we got the image up to our repository, and let's head over back to the diagram, and we can see here that we've got our image, but now we need to start doing this. We need to start sort of defining the services that the tasks and the services that we need to run in our application. And I'm going to do this with a mixture of scripts and following through on the console, on the Amazon console. So the first thing we're going to do is I'm going to head over to our terminal window, and I'm going to create a new cluster, and this is pretty straightforward actually. So we're going to going to use the AWS ECS Elastic Container Services command create cluster and give it a name. We're just going to call this Rails demo. You can call it whatever you like, and it's a pretty simple thing to create, but we need a cluster to get going. Now, the next thing that we want to do is, and you could do this in either order actually. So you could create the task definition first or the cluster first. I'm now going to anyway create a task definition. Okay, so the way that I'm going to do that is I'm going to run a command that I'll show you the command here. It's going to register a task definition, and it's just going to use an input JSON file, which is already in our project. And I'll show you that over here. It's in the AWS folder Rails demo, and this is the file. And it's I'm not going to run through this in its entirety, but it's probably the most minimum amount of information that you need to define a task. And as I mentioned, of course, you can do this through the Amazon Console UI. But I thought, well, let's just create it here as a JSON file and run it as a command so that we can use it later. Now, the interesting thing related to, say, Rails is the port mappings. So Rails runs on port 3000 by default, so I am mapping those ports, the host port to the container port of 3000. I'm also setting up a bunch of environment variables here, which mostly are fine, but there's two that we need to fill in here, the database URL and the secret key. Now, if we scroll down, we can see that there is the image here as well, which has the name Rails 6 demo. We've allocated 2048 of memory there. And we're saying that we want a 1024 for CPU. Network mode is AWS VPC, which is basically when you use Fargate, this is the network mode that is applied. It's worth digging into exactly what that means, but for now, we'll just leave it at that. I want to set the database URL. Now, as mentioned, we have deployed our database to RDS. So if we go back to our Amazon console, you can see here I've got a database called dev bootstrap Fargate demo. If we click into that, there is an endpoint right here. And this is what I can use for my part of my database configuration. So I'm going to head back over here and use that as the host. And then the username is Postgres. And the password is a secret password, but don't worry, I'm shutting this database down, so don't try to connect to it. After this video, it's going to be gone. All right, and here's the secret. Also not used anymore, but that's what you would do. So there's your database URL, Postgres protocol, then Postgres username, password, the host, and the secret key. And that should be enough, right? So what we can now do is I can register that. So I've actually, as I mentioned, I've got these README here, so I can use this command, AWS ECS, register task definition, and here I'm using the file protocol to pick that up. So let's head over here, let's run this command, and there we go. We can see the output looking as expected with the different parameters. We can scroll through that, take a look. We can also head back over to the ECR service, and we can click on Amazon ECS. And if we go into task definitions, we can see our task definition has been created. And it's versioned, so every time we create a new or update this task definition, we'll get a new version of it. So we click on version 1, since there's only one version. And everything in here is as per the configuration that we sent in. So you can see the task memory that's allocated for this task is 2048, and the CPU units is 1024. And also we can see down here the container name. We can see that it picked up the image, which is the image we deployed earlier. And if we expand this, we can see all the different configurations that we sent in, including the port mappings, the database URL, and the environment, and so on and so forth. So that's really awesome. Right, so what's next? Well, again, let's head over to our diagram and take a look. So we've got the container, we've got the task, we've got the cluster, actually, because if we go into cluster now, we should see the cluster we created. You see Rails demo is right there. So what's left is to actually start a service inside our cluster. And I'm going to do this using the user interface here. So this user interface is something which you're going to get used to as you use Fargate. But for now, what we need to do is create our first service. So let's hit the Create button. And we're going to choose Fargate. And we're going to choose our Rails demo task definition, the latest version of that. We're going to put that into our Rails demo cluster. We're going to call this service name, and we'll just call it Rails. And we want to just create one task. And we're going to leave the rest of these settings as they are and go to the next step and scroll up. For the VPC, I'm going to just create the default one. I'm going to use a couple of subnets. And then security groups is interesting because you can see here that it creates a security group for us, and that's fine. And port 80 should be fine, but just in case Rails needs something else, like just in case, for example, just for this demo, I mean, I want to run, or I want to get access to this on a different port, I can choose a different setting here. So I'm going to choose port 3000, and I'll just leave it for anywhere for now, but it's probably recommended to limit that to your IP address. But for now, we'll just leave it like that. So that means that we've got port 80 and port 3000 open on this container, or on this service, I should say, right? So load balance I'm going to keep as none for now. I'll go into load balances in a second when we upgrade this service. And we're going to just keep going, and we're going to click Create Service, and we should see all of these things go to green, and then we can click View Service down here. Cool. Now, it takes us straight to the task tab, and as you can see, it says no results, but we can see here desired count is 1. That means that we're waiting for a task to spin up. So we can hit the refresh button here a few times. Maybe it will load eventually. While we're waiting for that, though, we can check events. Events is something which, we can see there's an error, right? And this is good because we can see what is happening in our containers, what's happening in the services and stuff like this in terms of keeping our services running. And so Rails, or the service Rails, failed to launch a task with an error saying unable to assume the role, and then that role there. Okay, that was provided for this task. So we need to make sure that this role exists. So I'm going to go ahead and create that role. Okay, so I created that role off camera, so now the role is created and the service is started. So if we look actually under tasks here, we can now see that there is a task definition, it's provisioning. If we click on the task itself, what we can see is that it's in a pending state. So it's basically being fired up. It's being started up by our service, and it's using all the configuration that we set earlier. And so obviously, if we take a look at this container, you can see that it's using, as I said, the configuration from previous settings, and we will expect this container to go to a running state, hopefully very soon. Now, it's quite possible, though, that the container doesn't start up, and this is where you need to diagnose errors using the logs and using some output based on from Fargate. So let's have a look and see what happens. Okay, there we go. It didn't start, so there's an error. So let's have a look. Cannot start container. Let's expand this. I think we can see it here. Error response from daemon, failed to initialize logging driver, CloudWatch login screen, resource not found. The specified logging group does not exist. Great. So that is actually related to CloudWatch. So we can go into CloudWatch. And what we can do is we can create the logging group that we specified in our task definition. So if we look at logging groups here, and we click create logging group, we can give the logging group a name. And the name is what we specified in our task definition. Let's head over to ECS again and look at the task definition. Go into the task definition details here. And I think we can check the JSON here, possibly. We can see down in here, network mode, no, it's gonna be here. This is it, ECS Rails demo. So we're going to open that up like that. Never expire, or we can expire it after 7 days, probably better to do that. Click create. Logging group has been created. This is it here. Actually, this is not what we need at all. Just, we can delete that one. So this is our logging group. And now with that in place, we can go back to ECS, back to our cluster, back to our service, and back to the events. And we can see that it's now working. In fact, it says here Rails has reached a steady state. So the service Rails has reached a steady state. So if we look at the tasks now, you can see the task is running. We go into the task, you see everything is healthy and running. So that's pretty cool, because I was able to sort of take an error that I saw in my container, or in the task there, and resolve that error. Now, that's one level of error. That's when we're trying to actually run the container within a task, within a service. But of course, you'll get application errors as well, and that's where you need to utilize your logging, which is here. You'll see your logging output is here. This all looks pretty okay though in this case. In fact, you can see it's listening on port 80, localhost port 80. And of course, what we need to do is take the public IP address, which is this one in this case, and just drop that into the browser and see if that actually fires up and returns our application. So, and if it doesn't, well, there's an issue with our security group, most likely, or with the container itself. So it seems to be taking a bit of time, and that suggests to me that there is an issue with, most likely with the security group. So it doesn't seem to be responding. So we can check that by going back to our, all the way back to the service. Click on the service, and you can see the security group that we're using. You can expand that, and we can see here the inbound rules, and we can see that we've got port 80 and port 3000 coming in from anywhere. So that should be fine. Interestingly, the task itself is running, and it's telling me here from the logs that it's running on port 80. In fact, there is some output. It's actually got some output, but we're just not getting anything back to our browser here. Do I have the right IP address? Okay, I see some more output now, and we can clearly see the issue. It's saying that it can't connect to the database. In fact, we do end up with the famous Rails, we are sorry, but something went wrong message, 500 error basically, is the default 500 error screen for a Rails app. And we can see here in our logs that the reason is because it can't connect to the database that we've created. And this is a very common thing to happen when you're first starting up with Fargate like this. It's related to security groups, as I was saying earlier. And the trick is to basically give your database over here, this database, the security group settings for incoming requests, inbound rules, that match the security group that you are running your service. So I'm going to add that right now. So I'm going to add a new rule for Postgres inbound connections. And I'm going to say, please allow any inbound connections from this security group, which is our security group. This is our Fargate security group. And if we save this rule, then we can head back over to our app and hit refresh. And then we can see a different error, in fact. So if I go over here, we can see, I think, here, yep. We can see now that the database, my app staging, does not exist. And this is because we need to run database, we need to create the database, and we need to run database migrations. Because the Rails app, as I said, relies on this database being present, and it relies on the schema to have been migrated. So I'm going to do that by running a migration script against the database right now, and I'll do that using Rails. So I'll do that off camera. I've gone ahead off camera and redeployed the application. So here we are in our cluster. We can dive into the cluster itself and look at the service name Rails. And then in here under tasks, we can see there's one task running. And if we click on that task, we can see that it now has a new IP address of 3120130. Now, the IP address changes every time we deploy a service, which is fine if it's a task or if it's a private demo like this one. But if we wanted it to be behind a load balancer, then we'd ideally want it to be with a fixed IP address that we can use and maybe attach to a domain. But this is now running. I can show you it here. I've already opened it up and saved some product to the database. We can take a look at it and go back and add a new product and go back and so on. So this is all working. I also, like I said, I output the host name. This is so that we can try out this entire thing when we run this behind a load balancer. So let's do that right now. So what we want to do is go back to our cluster, and then we want to create a new service, right? Why do we want to create new services? Because we want now to create this new service using the same Rails container that we've already deployed, but this time using a load balancer. So I'm going to walk through this now really quickly. So we go through Fargate as a launch type. This is all the same, but this is going to be called, we call this Rails LB. So we know that this service is the Rails service running with a load balancer. And we want to use at least 2 tasks because we want to see how the load balancer works and sends our requests to different instances of the app. We're going to go for the same subnets, and the security group should be fine. As I mentioned, it creates a security group for us, which is just basically our standard port 80. Now here is where we get into the load balancer side. So before we had none, and as you saw, it's okay for a private demo, but it changes the IP address every time we change or update the app. So we're going to go for a application load balancer, and the first thing it says is no load balancer found, and you can see here there's the drop down and nothing is there, right? So we need to create load balancer using EC2 Console. So we just dive straight into that. We're creating an application load balancer, so we click create there. It's internet facing, so we're going to call this Rails LB demo, something like that, whatever. Internet facing load balancer, HTTP port 80, yep. We're going to use all of our subnets, and we are going to go to the next step here. This is fine. We go to the next step. We're going to use an existing security group. We use the Rails 5646 security group, which I know has got port 80 open. We'll just go to next. And then there's the target group. Now this is where we define what instances should the load balancer be looking for to target when a request comes in. So we're going to create a new target group. We're going to call this Rails target group, just Rails TG. And it's an instance of type instance, and everything else is pretty much okay. I mean, you can define a health check, but for now it's just going to be the root, but you might have in your container a health check endpoint that you could use. And we can run we can attach to different or register targets, but at this point we won't do that because we want to register targets that are in ECS Fargate. So this just gives us a quick overview, and then we click create. So once that is created, we can go back to, so we can see here it's created, but we can go back to our wizard here and refresh this, and now we can see the load balancer here. And the container to balance is going to be our container running, which we call Rails 6 demo, running on port 3000. Because what's going to happen is the request will come in internet facing on port 80, and the load balancer will then okay, that's not working. Okay, sorry. That's a new load balancer on port 3000, and target group is ECS Rails. Yeah, that's fine, and we can go to next step. So now we want to add to our load balancer by clicking this button here. And we're going to create a new listener port. So Rails runs on port 3000, and the target group name is going to be this ECS Rails D Rails LB. This is our target group. So this is telling the load balancer, okay, this is the target group that you want to send or forward the requests to. And we go down here and we click next step. And we can do auto scaling, but I'll leave that for now because we want to just check this load balancer. So we create the service. The service has been created. Now we can head over and view the service, and you can see here now for this service, which is a new service. It's called Rails LB, and it requires a number of tasks of 2. So we go down here. You can see that we also have load balancing configured, and we can see the target group name is this. Actually, if we click on that, it will open up the target group, and you can see the targets here will appear here once the tasks actually start running and are allocated IP addresses. So you see that appear here. So if we go back to our service and take a look at the tasks, you can see here the 2 tasks that we asked for have been started, and they're both in a pending state, but eventually they'll be in a running state. And if we take a look at one of them, the task will still be assigned a public IP, and we can probably hit the container directly using that public IP, but we won't in this case because we want to use the public IP of the load balancer that we created. The load balancer is here under the load balancers section of EC2. And so this is the DNS, this is the public load balancer entry that we want to use for testing this out. So I'm going to copy that, I'm going to open up a new tab, drop that in, and click run. So we start off with getting this error, 503 error, or 503 error, service temporarily unavailable. So I'm going to just knock this out of the dock here, and so that I can just have that running in a separate tab, and we can come back to this. Now the reason why this is unavailable is because the containers have not started. These tasks here have not started up yet. So we can keep refreshing, and now we have both of them are now in a running state. So that's cool. Now let's check the target group, and you can see that the target group has picked up the 2 IP addresses. These are the 2 private IP addresses of the service, but we can see that they're both in an unhealthy state, and this is why we're getting this 503 error. So the question is, well, why is this in an unhealthy state? Well, this is the health check settings here, and the health check settings is basically to this path. And we can edit this and take a look at this, but really the question is, why are we getting an unhealthy state when we make a request to this path on our container? So if we go back to ECS and we look at the tasks, you see the task is running, you see the logs, seems to be running okay. Well, so it turns out that we need to go into our security group, actually, the one that's running in the service itself, this one here, and we need to add an inbound rule so that the container can be reached. So port 3000 of the container must be open so that the health check, which is basically pinging the container, can actually return a status of healthy. So I've done that off camera just now, and now if we check the target groups, we can see that the 2 targets are running in a healthy state. And so these are the 2 private IP addresses of our containers that are running in ECS. So if we head over to ECS and we look at the tasks, and we open both of the tasks that are running, you can see if we check the IP address, the private IP address, you can see 172.3.145.225. And if we look at the target group, that's that one there. And if we look at the second IP address, it's 173.121.85. And again, that's the target group IP address here. So they're both coming up as healthy, which is great news, because that means that the service over here, the events of the service, will remain in a steady state, meaning that the service is now ready to serve requests and will not be attempting to fire up and refresh targets that are and tasks that are unhealthy. And that also means that, of course, our load balancer endpoint will respond with the app, which is here. This is our load balancer endpoint, and if I refresh, you can see that it returns the app. And now we can keep hitting refresh and see how it changes the request to one or the other of the instances running. So you see this is returned by the instance with IP address 172.3.145.225, which is this one, right? So this task here, the container running in this task, was returned by that request. Now, if I hit refresh, it's still the same. So if I hit refresh a number of times, eventually we see it switches to this IP, which is the task running here in this container. So we have a load balancer application that is spanning out the requests to our Fargate containers and alternating between the two. So that wraps up our screencast for today, and I hope that you end up using Amazon Fargate in your projects. Please, if you like this video, tell your friends, and I hope to see them here in the near future. And good luck with your programming, and see you soon. Bye bye.